I want to talk now about insecure direct object references. And this is where I'd like to draw an association back to OWASP. So I introduced OWASP at the start of this module, and I said that as we go through the course, I'm going to call out risks which they specifically address in their top web application security risk document. And insecure direct object references is one of them. Now, OWASP prioritized their risks based on a number of different factors, and you can see those represented in the table here. And those factors include things like the exploitability. It is easy to exploit an insecure direct object reference risk, and we're going to see just how easy in just a moment. It's also quite a common risk, and the detectability is also easy. And again, you'll see just how easy in just a moment. The impact they've classed as moderate, and it really comes down to the nature of the system. So what is the resource that the insecure direct object reference is going to expose to an attacker? This is their number 4 risk out of the top 10, so it is quite high on their list of risks. Let's jump over and do a demo so you can see just how impactful this risk can be. So back on our insecure site, what I want to do is jump up to the My Account item in the navbar and go down to Edit Profile. Now we've spent a bit of time on this page already during this module, and one thing that you may have noticed is that the URL appears to have an ID in it. So this is that very semantic routing-based URL that I spoke about in the introduction to the course. And if we have a read of it, it makes a lot of sense. This is the account for user profile number 1. Now when you look at a pattern like this as an ethical hacker, what you should be thinking is what would happen if I changed user profile number 1 to a different user profile. So earlier on in this module in the first demo, I showed how we could modify the user ID parameter when we voted for a vehicle to change it from my ID number 1 to ID number 10, which was Nico Rosberg. Let's see if that works here as well. Let's change 1 to 10. And here we have Nico Rosberg again. So what we've been able to do is directly reference the internal ID for this user profile, ID number 10, and that has pulled back his record. There is a lack of access control here. So at no point has the system said, hey, should Troy, who is presently logged on now, you can see my name there in the navigation bar, have access to user profile number 10. That bit's been missing. So the first thing is, obviously this resource can display other people's profiles. That in itself is a direct object reference risk. That is, of course, assuming that the system is not designed to do that. You probably shouldn't be able to edit other people's profiles. But let's actually validate that. Can we go and change Nico to Nico2? Let's now save his profile. And it looks like the profile has been updated. Earlier on, we voted on the Pagani. Let's go and see if Nico is still Nico, or if Nico is now Nico2. So we'll go up to the leaderboard, down to the Pagani, and scroll down to the comments, and now we have Nico2 Rosberg. So that change has actually been persisted in the database, and we have now changed someone else's name due to an insecure direct object reference risk. So you can see now why OWASP says the detectability is easy and the exploitability is easy, because all we've done is changed an ID in the URL. And this is a risk which we have seen many times on the web. And a canonical example of that is banks with account numbers in the URL. And all you do is you just change the account number to someone else's, and suddenly you pull up their banking data. That has happened multiple times with high-profile banks. So it is a very real-world risk.